Hey, what's up, coders? Welcome to One Little Coder. In this applied NLP tutorial, we're going to create a project that's quite popular all over the Python ecosystem. So the project that we're going to do in this tutorial is YouTube video summarization. Unlike most YouTube video summarization tutorials that take the caption of the YouTube video, where you can, YouTube API allows you to download the caption and then summarize it. We're going to actually perform a speech recognition. We're going to actually convert the speech, the audio, into text and then do the summarization. So far, I've never seen a tutorial like this thing. I'm not exaggerating, but I have literally not seen a tutorial like this while I was preparing for this video. So in this video, what we're going to actually do is we're going to take the entire speech of the video or from YouTube and then convert that speech into text and then summarize the text. So as you might have rightly guessed, this video has three parts. The first part is where we try to download the YouTube videos audio, and the second part is where we try to use ASR, automatic speech recognition. We're going to use ASR from Hugging Face using wave to vector model to convert all the speech from the video which is downloaded into text. After we have the text in place, we're going to finally do the summarization of the text, finally getting the summarized text of the entire video. So that's what we're going to do. If this is something that interests you, please hit the like button and also subscribe to the channel. Just an insight, more than 70% of our viewers are not subscribers, so I would strongly encourage you to subscribe to the channel so that you can get the notification of any new video. Without further ado, let's get started. First of all, I'm using a Google Colab environment. I'm using a Google Colab environment with GPU. So you can see that I have got GPU hardware accelerated on. So first thing, after you create a new Google Colab, click the runtime, change the runtime, and then select GPU so that you have GPU runtime for a couple of tasks that we do. If you have GPU, it's going to get executed faster. So the first section of the video, which is to download the YouTube videos audio. The library that we're going to use for that is called PyTube. And once you install PyTube, then the next thing is from PyTube, import YouTube. YouTube, just make sure that your Y and T are in uppercase. The next task that you have to do is you have to decide on the video for which you have to create summarization. Just keep in mind that the longer the length of your video becomes, the longer your summarization task is going to take, and also the more expensive your computational resources are going to be. What do I mean by that? If your video is 1 minute, maybe your summarization is going to take less than a minute. But if your video is going to be, let's say, 5 minutes or 10 minutes, you might also end up in a memory issue because the memory that you get could be limited when you get on Google Colab. Sometimes you might have to upgrade to Colab Pro. So there is a small trick that I'm using in this video to avoid that, but I still would request you to keep in mind that longer the video becomes, the harder the summarization task, transcription task, everything becomes harder. So if you're going to use it only for demo, or if you're going to use it for a hobby project, university project, or you want to add it to your portfolio, make sure that you try it with the smaller audio first, and then you can use a longer audio. The video that I'm using is a very popular analysis of President Barack Obama's speech. So this video, as you can see, it takes about 3 minutes 23 seconds as we speak. So we're going to take this video and then first download the audio of this video. So I've got the URL of this video, and this is the URL of the video, and then I'm going to say YouTube and video URL. So at this point, I'm ready to download the video's content. But what do I want to download? From this URL, I'm just using PyTubes to say from this URL stream, give me only audio. By default, when you want to download audio from YouTube, you have two formats. One is MP4, the second one is WebM. So instead of downloading it in WebM, we are going to download it using MP4 format. So after that, we are going to download, we are saying that, give me only MP4 format. And out of that MP4 format, you could have multiple resolutions, multiple bit rate, multiple sample rate. We are going to take the first element because it doesn't matter a lot for us what audio quality it is. But if you are concerned about audio quality, maybe this is the place where you have to tweak the code. Then we are going to download the file in a predefined file name, which is ytaudio.mp4. Of course, this is an mp4 file, so you need to give mp4. Once you run this, you're going to have a file called ytaudio.mp4. For our transcription purpose, for our ASR purpose, we need a .wav file. So we are going to convert this ytaudio.mp4 file into a ytaudio.wav file using ffmpeg. And we're going to make sure that our sample rate is 16,000 hertz. Okay, so ffmpeg input audio and using your codec blah blah blah, and then using the sample rate 16,000, you're going to convert into ytaudio.wav. After you run this thing, you are going to have a file name called ytaudio.wav. So from at this point, from now, we are going to deal with only ytaudio.wav file. So at this point, we have successfully managed to finish the first part of our video, which is to download audio of the YouTube video. So that part is done. And the next part is automatic speech recognition, ASR, which you can also call as speech to text. So to make it easier, we are going to use a library called Hugging Sound. Hugging Sound is a library that wraps around the wave to vector model to make it easier for you to do ASR. It's not just for English. You can use a Hugging Sound for any language that wave to vector supports. But because we are dealing with an English video, I'm going to use it only for English. The first step in this process, as every first step, you have to install the required library. The required library here is Hugging Sound. I'm installing it quiet. That's why you don't see a lot of verbose comments. After you install Hugging Sound, you have got installed Hugging Sound. After you install Hugging Sound, from Hugging Sound, import speech recognition model. So from Hugging Sound, import speech recognition model. Now at this point, if you are wondering why did this guy ask us to enable GPU, okay, this is the time. So if you have got CUDA GPU enabled, then we are calling the device name is equal to CUDA. If you do not have CUDA, which is GPU not available, then you can use CPU. Just mind you that if you have got GPU enabled, this transcription process will take lesser time than if you're going to do inference only on CPU. That's why we are leveraging the collab environments GPU that Google gives us for free. So here in this step, all we are doing is we are assigning device equal to CUDA if we have GPU. If we do not have GPU, device is equal to CPU. So let me run this. You would see device equal to CUDA. So because we have got GPU enabled. The next thing is we need to download the model that we want. This is the point where you decide what language you want to do transcription or ASR for. So in our case, we are going to do transcription / ASR for English language. So I'm downloading the English language model. But let's say if you want to do it for Tamil, if you want to do it for Hindi, if you want to do it for Spanish, German, whatever language that you want to do it for, you have to download the respective model. And where do you find this model? All you have to do is go to Hugging Face library and then start searching for the model. Then you would find the right model that you can use with Hugging Sound library. But right now we are going to stick with only English language model. So at this point, once you run this, you're going to download huge size of language models, especially speaking the speech recognition model. Once the speech recognition model is downloaded, you might think, oh, I can go ahead and then start transcribing. There is a twist here, and the twist is that if your audio is going to be more than 1 minute, you might hit an out of memory error. So it's called an out of memory, also known as OOM error. What does it mean? It means for a given computing session, you would have a limited amount of RAM. Limited amount of RAM means that is the maximum that you can use to do computation. But when your audio file size crosses 1 minute approximately, because I've done a lot of tests, sometimes maybe let's say maximum 2 minutes. But if your audio is going to become more than that, you cannot run it on a Google Colab environment. Sometimes you might have to purchase Google Colab Pro, or you might need larger GPU resources. To avoid that, we are going to do something called audio chunking. So to avoid out of memory OOM error, out of memory error, we are going to do audio chunking. What is audio chunking? Audio chunking is the process of clipping or splitting your audio, the longer audio, into multiple smaller chunks or smaller pieces, and writing them into individual files. So we're going to use a library called Librosa, and the library Librosa, we're going to read the file, and after that we're going to say cut the stream into 30-second chunks. You can increase the length, the block length. Here we have decided 30 seconds, but if you want to increase it, you can increase it to let's say 60 seconds, whatever it is. Just make sure that if your audio is going to be more than 60 seconds, you might hit out of memory error. So I would always encourage you to be conservative and then keep it below 60 seconds while you're going to use Librosa. So this process is called audio chunking. The one catch here is the audio chunking that we're currently doing is purely based on the time. It might happen that while you are splitting based on 35 seconds, it is possible that the speaker might be speaking something, you might be cutting a word into two half. If you want to avoid that, again, there is a very nice solution called what is the solution? The solution is called VAD, voice activity detector. So you can use something like Celero voice activity detector to actually extract the speech content from the speech and then split based on that. But I'm not doing anything sophisticated like that. I'm simply using 30-second blocks, and then I'm going to just cut it into chunks. Imagine our audio is like 3 minutes. 3 minutes is equivalent to what, approximately 180 seconds. So we're going to end up with 6 audio chunks once this process is completed. So now I'm splitting this audio, I'm creating stream of 30 seconds, and I'm going to run every 30-second chunk as a new file. And how do I save the new file? I'm going to just say 0.wave, 1.wave, 2.wave for every iteration, and I'm going to save it. After I do this thing, I can see that I've got 0, 1, 2, 3, 4, 5, 6. So I've got 7 chunks of file. At the end of this process, I have successfully converted my YT audio.wave, which is approximately a 3.5 minute audio, into 7 chunks of 30 seconds. You can see this is what 12 MB, and this is like 937 KB. Like it's less than 1 MB. You've got 7 files. So at this point, we are good to go with our audio transcription. So I call it chunk transcription. I would call it audio transcription slash ASR, automated speech recognition. So what are we going to do? We are going to take all these individual chunks and we are going to transcribe them into respective text. So we are going to do speech to text. Let me even write speech to text, whatever you would like to call it, transcription, ASR, speech to text. We're going to do that. But for us to do speech recognition or speech to text, we need to define the files, audio files for which we want to do transcription. So here I'm just simply creating an empty list, and for that list I'm just creating the file names. What I'm doing is I'm just creating an empty list where there'll be 7 string elements: 0.wave, 1.wave, 2.wave, like that. I'll go up till 6.wave, and this is going to be a list. So this list is called audio path. This will be given as an input to our model.transcribe function. So I've got an audio path list that has got 7 elements. Now this audio path is given as an input to model.transcribe. If you have forgotten, we have already downloaded the model using speech recognition model class. So at this point, we have successfully started the procedure of transcription with the 7 audio clips, and this process might take a little bit of time, and the transcription that you have got is not necessarily a text. If I run this quickly, transcriptions, you would see that it's not just the text. You've got multiple elements here. You've got the score. Let me quickly show you. I'm just scrolling up, and yeah, you've got the probability score. You've got the probability score that will tell you how confident a particular transcription has been. And then I think this is, I don't know, maybe it is n timestamp, and then this is the actual transcription. So imagine this is a list of dictionaries, and the value transcription is what you are interested in. So the next step that we are going to do is, let me tell you this. is to extract the text part from this. So I'm going to say create a new list called, sorry, new string called full transcript. And for every item in transcription, I'm taking the item's transcription value and I'm joining it with the with this full transcript. And as you can see, now we have the full transcript. If I run this, ideally you should have the full transcript. So this is ideally the full text of what President Barack Obama's speech is about. So this is not the caption that we download from YouTube, but indeed the audio transcription or audio speech to recognition or automated speech to recognition, whatever you would like to call it, speech to text, we have ourselves we have created. So this is the text which we want to summarize at this point. So now we have the input text. Now let's see how to summarize this input text, and that takes us to the final step of this project. Again, this project, just to remind you, YouTube video summarization using Hugging Face ASR. The final step is from transformers, we are importing pipeline. So pipeline makes it really, really easier for you to do any NLP task, the basic NLP task. So here in this case, we are going to do summarization. So I'm going to define my task as summarization. And because we have not defined any model, it's going to take the default model. But imagine you're going to do this for a different language. Like I said, Hindi or English, Tamil or German or Spanish or any other language, then you have to define the respective language model here rather than just letting it to download the English model. But in our case, we are doing it for English, so I'm not specifying any special language model here. Okay, so at this point, we'll define the object summarization. After the object summarization is defined, now you might think, oh, that's fine. Can I go ahead and do summarization? No, you cannot. This text is quite large for this model to handle, so it might be required. Let me first try if I'm going to get an error. What if I don't get an error? I'm just telling you that that you might get an error. So ideally, a lot of models, you need to chunk them into smaller text and then you need to do summarization. But let's see what happens with this model. Looks like it might be working, but I'm going to also explain you the text chunking part. Let me give a title: text chunking before summarization. Oh, it ideally worked. So a lot of bird based models, you cannot give text more than 512. The token size should be 512. I had that in mind and I was doing chunking, but thank god, like we finally did summarization without having to do chunking. So what is the summarization? We have got the full text and then it says in no other country something something something, and then it has got the abstractive summarization successfully done. So if you want to just extract the text, you can say summary text and then you would get only the text. So this is the easiest way to do summarization. But let us say you've got a very large document. Maybe you don't want to do summarization as a whole, but you want to do summarization for each and every paragraph or a chunk of text. So that is what this step is about, which is text chunking. Very similar to what we did with audio chunking. We are going to cut our text into 1,000 characters, and we are going to say for every 1,000 you're going to do summarization and then append the final summarization, and you get something like this. But once again, I think this is quite irrelevant at this point, text chunking, because at this point we have successfully managed to create the summarization of the original text, where you didn't have to do the chunking part. Before you think that what maybe what if this guy's notebook doesn't work, maybe what if this guy is throwing some crap at us, I would like to actually give you a new video and I would like to do summarization so you understand that it actually works. But this part might take a little bit of time because this is we're actually doing summarization at real time. So if you have already enjoyed the video, if you have got what is happening in this video, you can stop this video right now and then go start creating your project. Just make sure you share the video with your friends. But if you want to see whether this project actually works, just let's get started. I'm going to go to YouTube and I'm going to find another small video. I'm going to say I'm going to pick a very small video. So I'm going to say Batman interview. Let's say Batman interview. Okay. Let me see if I have any video that is quite small. So okay, this video about Robert Pattinson and Zoe Kravitz. look like a small video. Yes, I think that looks like a small video, 5 minutes. I'm going to take this video. I'm going to take the URL. I'm going to go to my URL. I'm going to create a new link. Comment this. I'm going to say video. This is how you would ideally do if you use my code. I'm going to say Batman. Okay. Let me see if I can find something smaller than this. Batman interview. Yeah, I think Colin Farrell's. This looks like, smaller video to me. This looks like a smaller video. I'm gonna pick this smaller one. Okay, Batman interview. And after I have this video, I'm going to execute this and I'm going to run this. I'm going to run this. And at this point, we are downloading the audio file into .mp4. Now we are converting that mp4 into a .wav file, ytaudio.wav file. It's asking whether the file already exists. Can I overwrite? Yes, please. And once you give the permission, it's going to overwrite. After you do that, you're going to come back here. Don't have to download the model. Now we have to do the audio chunking process. I'm going to say this is my input file. We already have the same file name, so we are good to go. I'm going to do chunking here, and I'm going to say save the new chunks. Save the new chunks. So one thing that you might have noticed is, how do I know what is the chunk level that I have to handle? So when this process ends, there is a I value, and that I value usually holds the last value. So I know there are like 8 chunks that are done. So I'm going to say I plus 1 and A from like 0 to 8 plus 1 9. I'm going to iterate my for loop, which means 0 to 8 is the wave file that I'm going to create. I'm going to run this and I'm going to run this. So you can see 0 to 8 is what my audio path looks like. At this point, I'm going to ask it to transcribe. And like I said, it's going to take a little bit of time because, of course, we have got a lot of file in there. So we have got 0 to 8. So what is the length of this video? I think it's 4 minutes. Okay. So transcription has been successfully done. Now we are going to extract the full transcript. Once we extract the full script, okay, someone has been very vocal about being a Batman, then for pretty mature, whole life, describe the feeling, something, and it's quite a very large text. You can see the text being quite large, and yeah, so you can see that it is quite large. So what are we going to do next? We are going to take this text and then we're going to do summarization. Okay, I'm taking the full transcript, doing summarization, and let's see what happens. This part may not be relevant again, like I said, and this might take a little bit of time because what is the length of this? Len, is len correct? Okay, it will not run right now because I'm, of course. Okay, this is weird. Summarized text equals, we load it inside this, and let's see. So full transcript is ideally available. Let's save the summarized text inside this. Live demo usually goes wrong. I think my demo is going to be a disaster, or maybe not. Oh, it's not. So summarize text. If I just get the summarized text, says the role. Ooh, what did I just get? Okay, I think I got what is it? Problem is this. Yeah. The role of Catwoman has been played by literally across years, I think. Okay. Trauma, like there are a little bit of typos that you can understand, but I think Batman is two sides of drama. Batman's born, and this is the kind of seed for which everyone else grew. Riddler. So I can say that maybe it's not like foolproof, like how you would see like a typical Google solution, but I would say you can optimize a lot of things in this. And our project is complete. Of course, it works. So let me tell you where are the places you can do optimization. First place where you can do optimization is make sure that you download high quality audio. That's the first thing. Second place where you can do optimization is when you're going to use this model, make sure you use the best wave to wake model. Third, when you're going to chunk the audio file, use the bad method that I just gave you, rather than just chunking it based on time. And fourth, when you're going to do summarization, when you're going to do transcript, combining the transcript, you can do summarization separately and then join them rather than joining everything and then do summarization. I think that kind of summarization would probably make more meaning than doing summarization like that, but it's up to you. The final tip where you can improve the model is, rather than just leaving it to the pipeline to download the default model, you can yourself define what kind of model you want, because you know the kind of text that you have got. So maybe you've got finance text, so you know now you have to use a finance model that might work better. So decide on the model that you want to use and then use that model here. And there are certain hyperparameters that you can use, like minimum length, maximum length, and so on and so forth. So you can play with all those things, like you can define a specific tokenizer. You can do a lot of things. So this is the final place where you can optimize this model. But having said this, we still have got successful YouTube video summarization using speech recognition or speech to text. Unlike any other tutorial on YouTube, we have successfully taken the video, converted into audio, converted that audio into text, and used the text to summarize. And we have got a full working solution in less than 30 minutes. You have really state of the art solution in applied NLP. I hope this video was helpful to you. This Google Colab notebook will be linked in the YouTube description. So all you have to do is click a like, if you want to, and then just go below the description, like below the like button, and then click the description and get this Google Colab notebook and then play with your own YouTube video whenever you want. If you have any comments, please let me know in the comment section. Otherwise, all the necessary links will be in the YouTube description. Make sure you check it out. Thank you so much for watching this video. Happy coding. Peace.